Okay, guys, so it says any polynomial with a divisor in the form of x take away k can utilize synthetic division instead of long division. We talked about this yesterday about how you can only use this synthetic division if it is in this form. We actually use this method of synthetic division with several other standards coming up as well, so even though you don't have to know it for now, it is going to be useful in the future. So for synthetic division steps, it's going to be very similar to what we did yesterday when we practiced doing the synthetic substitution. So you're going to notice the pattern of that is very similar in this one here. So step one is you bring down the leading coefficients and all the other coefficients from each term. Step two, multiply the leading coefficient by the k value. So that would be the value up here in the x take away k. So you have to be careful. If it's in the form of x plus k, then that means your k value would have to be negative, because the negative times the negative would make it a positive sign up here. Okay, so multiply the leading coefficient's k value and put that value under the next coefficient. Step three, add them together and repeat this process. A little note here is that the f of x, or the function of x, is the last number you write at the bottom right. Remember, the divisor must be in the form of x take away k. Okay, so example 1. So if you're given 2x cubed plus 11x squared plus 18x plus 9, and you're dividing that by x plus 3, remember how we were saying that it has to be in the form of x take away k. So that means your k value would have to be a negative 3, because we could rewrite this as x take away a negative 3. So my first step is to bring down my coefficients of 2, 11, 18, and 9. And notice that the exponents are in descending order of 3, 2, 1, and then 0. And then you're still going to draw your line like that. I know my k value is a negative 3. So first step is to bring down that leading coefficient of 2. Multiply it by my k value, which is a negative 6. Add these together, which is a 5. Repeat process. Negative 3 times 5 is a negative 15. Add them together, and I get a 3. Negative 3 times 3 is a negative 9. Add them together, I get a 0. So this tells me then that I don't have a remainder here for this one. There's no remainder. If I would have done the synthetic division from before, I wouldn't have had anything up here to add on to it, because my remainder is 0. So I know that my solution is 2x squared plus 5x plus 3. Example 4. So if I have x cubed plus 2x squared take away 6x, take away 9, and I divide it by x take away 2, I now have a k value of 2 if I follow that format of x take away k. So I pull down my coefficients, 1, 2, -6, and -9. My k value is a 2. My steps are to bring down my leading one, multiply it by k to get 2, add them together, multiply by my k value, add them together, multiply by my k value, add them together. So this one here, I am going to have that remainder to deal with. So I know that my answer is going to be a 1x squared, or just x squared, plus 4x plus 2 plus my remainder here, which is going to be 5 over, oops, that should be a -5. A -9 plus 4 is a -5. So I end up with a -5 there over x take away 2. This here is my solution. All right, example 5. So if I have x to the third plus 2x squared, take away 6x, take away 9, and I'm dividing it by x plus 3, my k value, I have to think of this as x take away a -3. So my k value is a -3. Once again, I'm pulling down my coefficients, 1, 2, -6, and -9. Put my k value out in front. Bring down my leading coefficient. -3 times 1 is -3. Add these together. -3 times -1 is 3. Add them together. -3 times -3 is 9. Add them together. So once again, this means there is no remainder. So I know my solution is x squared, take away x, take away 3. All right, now example 6 here is the 4-level problem. And the 4-level stated back here in the beginning, it says that you can divide the polynomials that incorporate fractions into the quotient. So I think we might save this part of the video for later and just let you guys focus on the sub today of doing the level 3 problems. Okay, so good luck and work hard with Mr. Stampfli.